So let's take a look at a specific heat problem or heat capacity. It says determine the quantity of heat. Whenever they say heat, for us, we're going to substitute Q for it. So Q is going to be heat. Kj is kilojoules. So often, in terms of heat, they want you to convert it to kilojoules. Required to raise 100 milliliters of water. So say you're heating up some water from 25 to 100 degrees Celsius. Couple of things, kind of recognize this as a specific heat problem. And so this is the specific heat equation. Whenever I'm doing this, I like to write down what I have, and you should have just one unknown. Another way of writing this equation is I can kind of cross multiply. I can write it like this. Q is equal to specific heat times mass times change in temperature. The specific heat of water you can look up. It's going to be given. It's 4.184 joules per grams degrees Celsius. Q is what we're looking for. So that's going to be either heat loss or heat gain. Now the mass, they gave you the volume. So we're going to convert that to mass. So we have 100 milliliters of water. We're going to convert that to mass in a second. We're going to use the density of water. Change in temperature, T final minus T initial. So in this case, we went from 25, that's my initial, and we ended up at 100 degrees Celsius. That's my final. And that's going to be 75 degrees Celsius. So T final is 100. We start off at 25. That's going to be our T change in temperature. Before I plug into this equation, they gave you 100 milliliters of water. You just convert this to grams. Use the density of water. So it's 1 grams of water per 1 milliliter. That's the density. So basically, it's 100 grams of water. So just to make it easier, when they give you milliliters of water, just convert to grams. To say it's 100 milliliters of water is 100 grams, 50 milliliters of water is 50 grams, etc. So now we're ready to plug in this equation up top. Again, when you're doing this, plug in all your units because we should end up with joules. So specific heat, 4.184 joules per grams degrees Celsius times our mass, 100 grams. And our change in temperature is 75 degrees Celsius. So we've canceled out our grams, we've canceled out our degrees Celsius, we're left with joules. And so this is going to be 31,380 joules. It's be joules, sorry. Yeah. They want you to convert to kilojoules. So the problem is kilojoules. And so we have to remember now, 1,000 joules is 1 kilojoule. So 31.38 or 31.4 kilojoules.